today we're going to do a quick review of Atwood machines and tension forces. If your Atwood machine has no friction and no mass, then you're going to use an F-net equation. F-net is the sum of all your forces in your object. So in this object, let's do 50 kilograms and 40 kilograms here. Even though these forces are both look like the force of Earth is pointing down on them, they're actually opposing each other. Since A is pulling, causing the wheel to rotate counterclockwise, and B is causing the wheel to rotate clockwise. They're opposing each other. They're pulling different ways. So A here is going to be positive. So you can do 50 times the force of Earth, which is 9.8, minus 40 kilograms, 9.8. And so your F-net, if I did the math right, is going to be 98 newtons. So that's your F-net equation. And F-net, remember, is equal to the mass of the system times acceleration. And remember that it's the mass of your whatever equation you're doing here. So this is going to be 50 plus 40, which is 90, times acceleration, equals your 98 newtons. And then you do 98 divided by 90 to get your acceleration, and you get 1.08 repeating, and the label for that is meters per second squared. So you got your acceleration. If you get to a question that asks for the F-net or the acceleration, this is all you need to do for Atwood machines. It gets more complicated when you get to tension. For tension, you either choose A or B. It doesn't matter which one you do, because you'll always get the same answer for tension if your Atwood machine is frictionless and massless. So let's do A here. So you're just going to only look at A. A, you got the force of Earth, which is pointing downwards, and then you get the force of rope, which in this case is tension. And then you just do an F-net equation for this only. Don't look at this one over here. It's only F-net for this one. So you set your F-net equal to the force of Earth minus tension force. I do it this way because since A weighs more, A is going to accelerate downwards, and B is going to accelerate upwards. And so I know FE is going to have more force than T, so I do a positive so I don't have to worry about pluses and minuses. But if you want to do it, we can do it the other way. If you want to do it F-net, and then just look at the forces here. If you want to do, since tension is going up, you can make tension positive, and the force of Earth negative, if you want to do the way the forces are pointing. But it doesn't matter which way you do it, you just got to remember which way it's accelerating. So if you did it this way up here, your F-net would have a negative acceleration, because it's positive acceleration, this one, because your FE is positive. That means your acceleration would be positive. But if you can't wrap your head around it, we can do it this way. So you set it MA tension minus FE, and your acceleration here is, because A weighs more and the system is going to accelerate this way counterclockwise, your acceleration is going to be pulling you down. So you're going to have a negative acceleration. So you're going to mass times negative 1.08. That's your acceleration pulling you down. Accelerating downwards is equal to tension minus, and we can just plug in force of Earth from over here, 50 times 9.8, which gets you, I believe, 490. And then your mass, it's not the mass of the system over here, it's the mass only for A. It's only A. So it's 50 times negative 1.08. and then you'll get negative 54.4 repeating equals your tension. And then you just add 490 to each side. And so your tension is going to equal 435.5 repeating. And this is in newtons. So this is your answer for tension. Tension's pretty easy if you remember that mass is only in the system you're doing. It's not total system. And your acceleration is whatever you set your force is equal to in the F net equation. If you made force of Earth negative and A is accelerating down, you make acceleration negative. But if you made force of Earth positive, it's going to be positive acceleration because it's accelerating with force of Earth. And then with B, since B is going to be pulled by the tension, let's do B over here real quick. Since B is getting pulled up, that means if you do your force of Earth and your tension, that means if you set your force of Earth negative and your tension positive, it's going to be a positive acceleration because acceleration is going upwards. So just remember your mass, your acceleration, and just try not to mix up those negative and positive signs, and you should be all good. So that's all you need to know for Atwood machines and tension forces.